So, okay, welcome to the Blitz. This is Mr. T, and today's Blitz, the skill that we're working on is this one right here. It's a really important one, okay? So it's this idea that a parabola, right? The shape is called the parabola here, right? Let me get my screen up. Okay, hopefully you can see this here. The shape is a parabola, right? We always learned that parabolas were the shape that was formed when we had an equation that it was a quadratic equation. So I'm going to look over here and kind of show you something. Well, actually, we'll get to there in a second. So if I were to graph a particular quadratic equation, it would form this parabola right here, okay? And in geometry, what we're supposed to understand is that there's another way to define a parabola. I'm going to build, this is a little parabola machine here, and I'm going to build another one so that you can really get it, okay? So here we go. I'm going to put in a point. All right. So we'll just put in a point. I'll put 0, comma 4. So there's point A right here. Okay. And I'll check. I'm going to have to check back and forth on the chat if you're doing all right. And let me just tell you also, if you're on the chat, you don't have a Twitch account, that's okay. One of the things you can do is you can use your Gmail. Okay. Go to your Gmail. Okay, over here on the sidebar of your Gmail, you can click plus, right? And this will give you, a hangout, right? You can put in my name, Mr. T. Here I've got, you look Dan Tomander, Thomander, right? Put that in there and it'll bring up my name. And then once you've done something like that, so here I pull up Mr. Pettis, for example, and you can hit this recording, call me, and I can listen to you and we can talk. So that's an option. Or you can just type me a text as well. You can just type it in. So if you have a question or you want to give me a call, feel free to give me a call, okay? Other than that, I'm just going to get working on this blitz because we want to get you earning your, demonstrating mastery as soon as possible. So let me get this, close a couple things out. And I'm sorry about this. I'm going to get myself caught up from what we were working on, get my lift project out of the way, the calendar out of the way, and go back here. So here's a point. We know what a point is. A point is just simply a location. So we use coordinates like X and Y coordinates to tell us exactly where the location is, right? I'm going to put in a line here. A line, the equation of a line, here I'm putting in y equals -4. That equation, if we graph it, it takes the shape of a line, right? So here's a line and there's a point. And now we say that in geometry, we say, hey, we can define a parabola as a certain shape. Now, I want you to think about circles, right? When we define circles, what we do is we say a circle, here I'll make a circle here. A circle is all of the points that are the same distance away from a center point. So we start by defining where's the center, and then we define the distance, the radius. And that gives me the circle, right? So the center and the radius. That is how we define a circle. Well, how do we define a parabola? The parabola is a set of points again. They're equidistant from this point, but they're also equidistant from the line. Okay, this point we're going to call the focus. Okay, this line we're going to call directrix. So let me put those words in here because you need to remember these words. Okay, so this word we're going to call the focus. Okay, and this word down here we're going to call the directrix. Okay, so this is just background to make sure you understand. Every parabola can be defined as having a directrix and a focus. All right, the next thing that you need to know is kind of how that would work. I'll show you how this would work. If I place a point on, oops, let me undo that. Click the wrong place. Place a point on that directrix, right? When I try to move that point, now you see it stays on the directrix. What I'm going to do is I'm going to make a segment that connects them. So this is the distance between these points, right? The segment represents the distance between these points. If I find the perpendicular bisector of this segment, then these points here are equidistant from A and B. So any point I pick here is going to be equidistant from A and B. And B, if you recall, B is just a point on this line somewhere, right? So when I want to measure the distance from B to, some other point up here, or from the line, if I was going from B, I could go diagonally, that's fine. But if I'm going from the line, I always measure the distance from a line on a perpendicular. So you do not have to memorize this stuff. Okay, this is just kind of background knowledge. So here is the perpendicular. So to measure the distance from the line, I have to measure it on a perpendicular. Okay, I cannot measure this. Oh, look, this is 5 units away because I went way over here to the left. No, it's really close to the line still, right? So I only measure how far something is from the line going perpendicular to the line, never diagonally from the line, right? So what that means is the distance from here to this point, which I would maybe call the intersection point, right? The distance, so from B to C, is going to be the same as the distance from A to C. Why? Because it is on this perpendicular bisector. So, and I'll build those segments right here, AC. As you can see, AC, that's listed as segment J, and the measurement over here is 4.72. And BC, which is listed now as segment K, it's also 4.72. Now watch what happens when I move B. Those two distances, right, 4.88, 4.88, they are the same distance, okay? So I've just built what we call a parabola machine, okay? This point C swings around to keep itself equidistant between the focus and the directrix. And the further I get away from the directrix, watch what happens. The further away I get from the directrix also has to get further away from the focus, right? It's far this way, so it has to go far that way. And that's why when you see a parabola, it swoops up and down like this. It swoops up and down. So now what we'll do is we'll just hide some of the stuff that we don't need. We want to see the focus. We want to see the directrix. It's there. It's the focus and directrix words. But we don't need to see the point. We don't need to see that segment. We don't need to see perpendicular bisector. We need to see the perpendicular line. We do want to see C. And we don't need that segment there. And I don't need segment K. So now what happens if I animate B is that you see that C is moving around. And I'm going to go ahead here and trace this one here. So this, as we move this, I'm going to speed it up. You can see that the shape that this will take as C swings around is the form of a parabola. And if I speed it, or let's see. If I let that go real slow, it'll swing around and it'll fill it in. All right, so why is that useful to us? Well, what we have to do is somebody's going to give us this point, right, and this equation, and they're going to tell us the focus and the directrix, and they're going to say, okay, what's the equation of the line of the parabola that has a focus of this and a directrix of that? Okay, so what I want to show you is we'll have this swing around again. I'm going to pause it. Okay, so I'm going to pause it here and set it up to where I can draw a little bit on this. All right. Okay, I'm going to pause that there, and let me get point B again where I can see it. And I'm going to move it over here. All right. And now I'm going to zoom in a little bit. All right. So what we know is this distance right here and that distance those two distances are equivalent. So let me get my, where is my drawing tool? I don't remember. There it is. There's my pen. From here to there, right, that distance has to be equal as from here to here, which is this distance, okay? And so now I got to start using some coordinates for this, okay? I've got to start using some coordinates. So what we usually do is we'll use like, for the focus, we'll use the letters H and K. We don't know what the coordinates are here. The coordinates that we'll use for our points on the parabola, so this point here would be x, right, and y, okay? And then this point over here, okay, this one we do know y, right? Y here is going to be, whatever this value is here. So I wish I had another color in here. This isn't all that great. I might have to pause this recording and come back in just a second because I'd really like to use some different tools here. But let me just try this real quick. So anyway, this point, I don't know what x is, but x, this is on a perpendicular, so it's the same x. Whatever x this is, this point C is, this point down here is going to have the same x. So it's going to be still x, right? And then this right here, we're using this y equals -4. So I know this is going to be -4, right? And then I would just put the coordinates in that they gave me. So this would be really, this is 0, right, comma, -4. 0, -4. So now I can just use the distance formula, okay? So I'm gonna show you what that would look like. So it would be the distance formula for this segment right here, right? For this segment right here, right? From A to C would be, right? We take x minus 0 right? And I'm gonna do this by hand here and square it and then add in the difference between y minus, oh, that's +4. Sorry, this is 4. So y minus 4. I'm going to do these by hand with my dot cam. And we should still, so that's my equation right here, okay? Let me switch. Let me get my dot cam up. Take just a second. Sorry for the delay here. So you're going to follow along. I'm going to do some algebra. We're going to end up with an equation that works pretty good, okay? An equation that'll work pretty good, okay? All right, so just a second. Sorry about this here. Give me a second here. Get my thing up here. I'll check the chat room. Okay. Don't know who's on, but here we go. Okay, I'm going to make this big. And then I'm going to, oops, go to my studio and edit my layout. And the main, I'm going to edit this. And I'm going to go to my dot cam. Actually, you know what I'll do? I will just go to my entire desktop. Uh-oh, just a second. So, here we go, my entire display. All right, I hit done there, and let me pull up this here, okay? So hopefully you can see this, okay? And let me move this thing out of the way here. Let me try to zoom in a little bit. So if you remember, and just try to do this real quick, if I had an equation, right, and I had a focus here, and that focus right here, I'm going to call this like H and K, right, which in this problem right now was 0, 4, right? That was H and K. And then I had this directrix was a line we called y equals -4, right? So, and then I had some point here called B. If this was A, then this was B right here. That point, oh boy, can you see that okay? Let me hit the, hopefully that becomes a little bit sharper. The glare's not so bad. Okay, so point B is some point on this line. So we're going to go x negative 4, some point x that moves across, but the y value is fixed at negative 4, right? So this perpendicular line goes up. It meets the parabola, right here somewhere. So this is the points of our parabola, which we're going to call x and y. So now I've got to find what is the formula for this and the formula for that, the distance formula for this. So I would go x minus 0 squared. I'm looking for the square root of, and then y minus 4 squared, right? That would be this distance right here, right? And then this distance right here, right, we're going to define that as right, the square root of x minus x squared plus y minus a negative 4 squared, right? So I'm going to just simplify this. This is 0 squared and 0 plus, so this becomes just the square root of y plus 4 squared. And hey, those two will cancel out. So this distance right here, its distance is actually just y plus 4. Whatever this value is for y plus 4 more. That's this distance right here I'm going to stick with for now. Okay? So the thing is, I know this distance, right? This distance here is y plus 4, whatever height that is for y, plus 4 more down here, right? So y plus 4, this distance, has to be equal to that distance, right? So I would put that in, I would say x minus 0 squared plus y minus 4 squared. Take the square root of that, has to be equal to y plus 4. Okay, now I'm just going to do some algebra. You do not have to do this yourself, but I want to show you. You can kind of follow along. If I square both sides here to get rid of that square root sign, right, this is just going to turn into x minus 0 squared plus y minus 4 squared. It gets rid of this, and the square root sign cancel out. Then over here on this side, we have y plus 4 squared. So y plus 4 squared. If I square that out, okay, what will happen is let me draw that out and let you see it here, right? So if this distance was y, right, and then over here I had 4 more units, then this distance here was y, and then down here I added 4 more units, right? Well, what would that be? Well, this would be y squared, right? The area here would be 4y. The area here would be 4y of this rectangle here, right? 4 times y. And then this area would be 16, right? So if I try to find the area of the whole thing, y plus 4 times y plus 4, I'm going to get y squared plus 8y plus 16. So x minus 0 squared plus y minus 4 squared equals y squared plus 8y plus 16. All right, now I'm just going to simplify this a little bit. X minus 0 is just x, so this is just x squared. Right? This just becomes x squared. And now I have y minus 4, which is a lot like y plus 4. The only difference would be this would be minus and a minus sign, and then the negative and negative become positive. So the only difference between this and this is that the 8y would be negative, so plus y squared minus 8y plus 16 is equal to y squared plus 8y plus 16, right? So let's do some simplifying here, really easy. This side has to be equal to that side. So can I subtract y squared? Yeah, let's get rid of y squared from both sides. Can I subtract 16? Yeah, let's take away 16 from both sides. And then can I add 8y to get rid of this? Add 8y to both sides. So what would I end up with? I'd have x squared is equal to, this is going to cancel, right? This is going to cancel. And I'm going to end up with that canceling, and that canceling, and that canceling, and I'm getting 16y. X squared equals 16y. And then if I were to divide both sides by 16, I would get y equals, right? Here's the y. I divide by 16 here, and that cancels, right? And I get y on this side, right, equals, and then on this side I just have x squared over 16. So y equals x squared over 16. So if I put this in my parabola machine here, right, in here, right, I'm going to erase all this stuff here. I don't know if I can. Well, it doesn't really matter. I just take this stuff off here. Okay, so we get rid of all that stuff. So you can go back to seeing just what we had before, right? So now we've got B, C, and A, right? In fact, I don't even need to see B anymore. And I'm going to just use this tool here. And now I'm going to enter in this equation. The equation that I had was y equals, and then I'm going to put x squared over 16. And if I do that, right, that's the formula I came up with. There it's drawn for me, the equation of that, or the graph of this equation. So these are all the points that are true for this. And you can see now when I go back and animate B, right, that what it does is it follows along that parabola perfectly. Okay, it follows along that parabola perfectly. So I have derived the equation by thinking about how these points here from A to C, the distance between A to C is equal to the distance between C and the directrix, okay, for this particular problem, okay? So this is what we need you to do is I'm going to give you a focus and a directrix, and you're going to have to come up with the the actual equation for that. Now we're going to make it kind of simple. So what I'm going to do is I'm going to make this point here HK, and this directrix here I'm going to make it negative k, y equals negative k, so that it is the same distance from the origin, okay? And then that makes things a little bit simpler, okay? So let me get my little pen out here again, and I'm going to just make this note. This point is H. I'm thinking of the focus as HK, right? Ooh, it doesn't like to, it's a lot of work for the computer to figure out and do all this while that's rotating around. So I'm going to leave that there. So this point is HK, right? Point C, the points on the parabola, right? The points right here, we're going to call those XY. And then this directrix, we're just going to use Y equals negative K, whatever I put in there for K. All right, we're going to go back to the paper, and we will recalculate everything doing that again. So here we go, back to my paper. So again, I'm going to draw this out. Here I have a focus. My focus is at HK. Okay, my directrix is Y equals negative K. All right, my point on the directrix at any given moment then is going to have a coordinate of X comma negative K. Okay, and then this point, the parabola's points, are going to be again at X, Y. They have the same X value because it's perpendicular, right? And then the Y value is changing as X changes, right? So let's do again this formula, only now we're going to use HK and X minus Y. So we would go, so X minus H squared plus Y minus K squared, right? Take the square root of all of that. That's our distance of this segment right here. This segment's going to look a little different. We go square root of X minus X squared plus Y plus K squared, right? Or Y minus negative K is going to be Y plus K squared. Okay? And then we'll simplify this again. X minus x is 0. 0 squared is 0. 0 plus this. So this is just going to go away. That becomes 0, right? So this whole thing is just y plus k, square root of y plus k squared. These two are going to cancel out. So this is just y plus k. That's our length here. Y plus k on one side. So we have y plus k on the one side of the equation. The other side of the equation is this thing, right? So we're going to put the square root of x minus h squared plus y minus k. Again, you don't have to do this. I'm showing you this for a moment so that you can understand how we got here, okay? And to do the algebra, what we'll do is we'll square both sides to get rid of the radical, to get rid of the square root sign. When I square this side, I get x minus h squared plus y minus k squared is equal to y plus k squared. When I FOIL this out, what do I get? Well, again, I multiply that out. If this is y and this is k, right, and this is y and this is k, right? So what would I get? I get y squared, I get ky, I get ky, and I get k squared, right? So, oh boy, there goes my machine. Let me see if I can get that. Uh-oh, a little bit of a problem here. Hang with me. Close that out. I'm going to close this thing out. Stay with me. Okay. Hang in there, guys. Are you still there? I haven't checked up. I haven't looked up for a while. I'm going to hit save. Have you been watching? Okay. It looks like you're hopefully still with me. Okay. I hope you're still there. So this is going to be y squared plus 2ky plus k squared. That's on one side of the equation, y squared plus 2ky plus k squared. Then over here, we've got to square everything out here, right? So we have x minus h times x minus h. That's x squared minus hx plus h squared. So we get x squared minus h minus 2hx plus h squared. So this, once we expand it out, becomes x squared minus 2hx plus h squared. Yuck, right? And what do we have here? We have another one we need to square out, right? I'm going to do that up here because I just have a little bit of extra space. So this is y minus k. If I square that, I get y squared here minus ky, and then plus k squared. So I have to add in a y squared minus 2ky plus k squared. So this whole ugly yucky thing is equal to that whole ugly yucky thing. So let's get rid of some of this stuff, right? So let's start by subtracting the y squareds. Well, that's going to cancel and that's going to cancel. Let's subtract the k squareds. Minus k squared, that's going to cancel. Minus k squared, that's going to cancel, right? All right. If I add 2ky to both sides, 2ky, I get 4ky on one side of the equation is equal to x squared minus 2hx plus h squared. Okay? So I've got to solve for ky. I've got to solve for y. And what I need to do is divide by 4k. And I end up with y equals x squared minus 2hx plus h squared divided by 4k. And this is my equation. That's my equation right there. Okay, y equals x squared minus 2hx plus h squared over 4k. So we're going to use this formula here. Okay? The only rule that has to happen here is that the focus and directrix must be equidistant from the center, right? They must be equidistant from the center. So let's try that on a problem so you can see how you're going to have to do it. So I'm going to give you a focus. Let's try giving you a focus of 2, 3. So if I said, here is a focus of 2, 3, okay, and a directrix, I would always say y equals, it has to be equidistant from the center. 3, it's got to be -3. I always just take that y value and change it. Okay? And now I'm going to use the formula, right? So this formula that we just derived said y equals x squared minus 2hx plus h squared over 4k. So I got to just remember, this is h, this is k, right? This is also, that's negative k here, but we don't need to worry about that because all we have to do is plug in h and k wherever we see this here, right? So y equals x squared minus 2 times h, 2, right, times x plus h squared, 2 squared, all of that over 4 times k, which is 3. And then I'm just going to simplify this a little bit. So y equals x squared minus 4x, right? Because 2 times 2 is 4, plus 4, all of that over 12, okay? And then what we like to do sometimes is just break these terms out. So I would say y equals, this is 1 in front of the x squared, so I would just call this 1/12 x squared. See, I'm using the denominator for each, dividing each of these in, I'm separating these terms out. So this would be 1/12, this would be -4/12, right? Minus 4/12 x, and then plus 4/12. And then I could kind of reduce that fraction. Y equals 1/12 x squared minus, and then this would be 1/3 x plus 1/3. So all I did was I took the equation given to me, 2, 3, and I made up a directrix, recognized what was h and k, right? And I plugged in the h here and the k there. And I plugged it in, and then I just multiplied and just kind of simplified it. Okay? And now I'm going to test it. I want to make sure it's actually right. And hopefully Mr. T did not screw this up for you. So I'm going to go here. And I'm just going to start a new document here. Let's go for here and go with a new and don't save. Okay. So the first thing I'm going to do is I'm going to put my equation in of the parabola, right? Which was y equals, and then I've got to do 1/12 x squared plus, minus, and then 1/3 x, right? Plus, and then I'm gonna go, let's go 1/3. So there's my parabola there. Okay, that's the parabola that I came up with. It is supposed to be the set of points that had a focus, if you remember. All right, had a focus of 2, 3, and y equals -3. So I got to plot 2, 3, and I got to plot y equals -3. Okay, let's scroll out. There they are. So now I'm just going to quickly test this out to prove. I'm going to put a point on there. I'm going to construct you don't have to do this part. I'm going to construct a perpendicular to that line goes through B. I'm going to connect a segment between A and B. I'm going to find the perpendicular bisector of that segment. I'm going to find the point. I'm going to actually drag this so I can see it a little better. Okay, I'm going to find the point. So I'm going to find the intersection point of the perpendicular bisector and this perpendicular line. That's point C. And now I'm going to be able to test it, right? Supposedly, the parabola are all these points C that are going to be equidistant from A and the line, the directrix, from the focus and the directrix. And I just go up here and I animate. And as you see, it is. It shows me that C is all of those points. C stays on this parabola. So let's go back and make this simple one more time. Okay, we've been in here for a while, but I want to make sure you've understood this concept and that you're ready to do this. Let me go back over here, just check. Have anybody? Your computer screen shut off and shut down. We're on paper. That's okay. Hang with me, man. I'm gonna send this to you. Can you still hear me? Okay. And hopefully you can. Because what I'm going to do now is I'm going to just give some practice problems the way they would look like for anybody that's on. Okay, so you're staying with me. Okay, so here's how the practice problem looks. Okay, so we pick a focus. I'm just going to go back to my, let me just stop this because that's just wasting bandwidth there and go back here. So what we'll do is take a problem like 3, I don't know, 6, doesn't matter, right? And that would be my focus. And then your directrix is going to be y equals, and whatever number you have here, -6. And then my formula I'm going to use is y equals x squared minus 2hx plus h squared. All of that over 4k. And then that's what the problem, I won't even give you this. I'm just going to give you those two and say, what is the parabola? What is the parabola that has a focus of 3, 6 and a directrix of y equals -6? You have to have this in your notes somewhere, right? You got to have this. You got to know this. And now what we're going to do is remind you how to do it. You go, this is h and this is k. And you just plug them in. And you just go y equals x squared minus 2 times 3. I'm getting 3 is the h, right? Plus 3 squared over 4 times 6, which is 24. Okay? And then you can just try simplifying this out. I would simplify it a little bit more. X squared minus 6 plus 9. Oh, that's, sorry, there's an x in here too, right? Because it's 2hx, so 2hx, so 6x. So x squared minus 6x plus 9, all of that over 24. And then you would just separate this into 3 parts. So you'd say y equals 1/24 x squared minus 6x over 24, or actually just move, I would just move the x to the side. That doesn't work very well, but minus 6/24 x, right? And then plus 9/24. And then if you can simplify, right, this would probably be a good enough answer, but we should try to think this is 2 times 3 and 24 is 8 times 3. So I can reduce the 3's, and actually this is 6 times 1. What am I doing? 6 times 1, and this is 6 times 4. So we can reduce the 6's, and this becomes 1/4. So I would rewrite it as y equals 1/24 x squared minus 1/4 x plus, and then this is 3 times 3, and this is 3 times 8, and get rid of the 3's, and I go 3/8. Now, if you need to, you can get, this is not a test of whether or not you can reduce fractions. It's nicer that way. It's cleaner. It's more proper to get it like this, but this would be my answer. Okay, and the only really, I think most of the really hard part here is remembering the focus is h and k, and you put h here, right? And knowing this formula, I put h here and then the k down here, and then it's just about doing a little multiplying, a little squaring, right? And then dividing it into 3 separate terms and then reducing. Okay, and then you're there. Okay, so what I want you to do, right, because you're on a blitz, you're trying to prove, hey, I can do this. I can come, if you give me this part right here, Mr. T, I can give you that part right there. So what I want you to do is I want you to save this, right? You should have this in your notes, right? Save that in your notes, and then you're going to make a recording where you pick a point, right? And if you want me to pick it for you, I can. You just tell me, right, and I will email you a point to be a focus and a point to be your directrix. And I would encourage you to use this formula. These two have to be the same values, just opposite signs, right? K and negative K. They've got to just be opposite signs, okay, in order to use this formula. And that's okay because we're not going as deep into this as we could. All right, so a focus and a directrix, right? And then what I want you to do is you're going to simply do the math like this and record an explanation for how you did it. And you say, well, I'm using this formula. This formula, you can explain it comes about by setting the distance between the focus and xy and the directrix and xy and setting them equal to each other. That you do not have to derive that equation. You just need to be able to pull from, given a focus and a directrix, return the equation of the parabola. So you got to do that part. Okay, I'm going to check in with you here. What have you got? All right, what have you got? All right, so let's see. I've got Rusty. Rusty says, all right, when you reduce, that's for the parabola, correct? What do you mean? Yeah, well, that equation, right? And it says, what is the name of the formula? So I guess this is just a formula we created right now, right? So I would call the formula of a parabola with focus at HK and directrix of Y equals negative K. That's what I would call that formula. That's a long name for it, right? But it's a specific formula. It only works for, when given a focus, we use the term H and K, and the directrix has to have the same, has to be equidistant from the origin for this to work. Okay? Now, if we were doing expanded Alg 2 college prep work, which is not really what the intent of the BLITZ is, but if we were doing that, then what we would do is we would probably want to add in some extension there. So anyway, I'm going to have you record that. Do you have a question about how to do that? If you need, and if you want me to give you a focus and a directrix, I can do that. McCoy, I don't know who else is on here. Let's see my viewers list. It looks like I got quite a few on here right now. And I don't know who they are other than McCoy. So if any of you guys want, I can shoot me an email or a pop-up or something. I will send you back a focus and a directions if you want to use it. And the link to record that. Let me see. I think it's in Flipgrid. I would use Flipgrid. So let me just try pulling that up real quick. See if I can get that here. Flipgrid. All right. See if it can come up for me before too long. So this is an Algebra 1A. This is not the right one, but I'm going to check Geometry B instead of Algebra 1A. So let me, where would I look for this? Sorry, man. Let me go here, get signed in as an educator here, whatever. And hopefully I'm going to see different classes. Get the link right here. All right, I got a Geometry B. So there it is. And wow, so really a lot of sign-ins for Flipgrid. Whew. All right. This one is equations and lines. That's not the one I want. Let's go to distance between 2 points. I don't want that. Equations and lines or distance between 2 points. Why am I not? Ah, man, that's kind of messy. So I'm managing my grids. So I'm going to edit this grid. All right, that's the one. So there's the link. Control C. I can put that into, let's go into the chat here. So here is the link to the chat or to the flip grid. So you go flipgrid.com/ okay, and then that would get you into this class to do it right. And then let me go to let's see, where would I? Okay, update the grid. So I'm going to add in a new topic. Here it goes. Here it goes. The new topic is so given, let's see, equation of a parabola. Okay, and we're going to give you a couple of minutes here to record. Well, we'll just go with 5 minutes. You don't need that long, hopefully. But here, given the focus and directrix of a parabola, provide its equation. In this flip grid, explain how you used the given formula to derive the equation of a parabola given the focus HK and directrix y equals -k, period. Okay, and I'm going to go ahead and create that topic, and I'm going to copy that link. So to get the direct link in here, here is the direct link to the flip grid for this exact topic. Okay, well, there it is. And I'm going to email it to you, okay? A focus and directrix, I'll do that for you. Okay, so let me, I'll take care of that here in a second. I'm going to do that offline, okay? And anybody who's needing any help, you let me know. But otherwise, that is it for the Blitz today. Get that recorded and email it back. And if anybody else who was here needs also, I'm going to be sending it to McCoy, but anybody else who needs it, just let me know, okay? If you have any questions, you can check in. My schedule tomorrow, 10 to noon, I'm doing Geometry A. So anybody who wants to sit in on Geometry A lessons tomorrow, from noon to 12:30 is our break. 12:30 to 2:30 is STEM Academy again. And that's where we're going to go, and I'll let you know about Blitzes coming up. Okay, thanks a bunch. Good luck to you.